So we're gonna go through the November 2020 question paper, the chemistry side, and we're gonna go through question 6. So yeah, let's get started. They say the dissociation of iodine molecules to iodine atoms is a reversible reaction taking place in a sealed container at 727 degrees Celsius. And they give you your balanced equation here. So they tell you that the equilibrium constant, the Kc, is 3.7 times 10 to the exponent -3. And now they're asking you what's the meaning of the term a reversible reaction. So what I would say, a reversible reaction is basically a reaction that can be reversed, where the products can be converted back into the reactants. So now they say at equilibrium, the pressure of the system is increased by decreasing the volume of the container at constant temperature. And if you know the factors that affect the equilibrium constant, because I think I have gone through that part of what affects the equilibrium constant and what affects the chemical equilibrium. I think we've gone through that together, right?
I think so, yes, sir.
Okay, so now they ask you how will each of these be affected, and they say the value of the equilibrium constant. Since you know that temperature is constant and temperature is the only one that can affect the equilibrium constant, you know that the equilibrium constant is going to remain the same since the temperature is kept constant. And now they're asking you about the number of iodine molecules. So when you decrease the pressure, when you increase the pressure, you're going to favor the side with more moles. So since you're going to favor the side with more moles, that means the iodine atoms will increase. So the number of iodine molecules is going to decrease. Do you understand that part?
Yes, sir.
Okay. So let me just check this. They want you to explain with Le Chatelier's principle. So do you know like have you had a question like this maybe in your class test or something like that?
Yes, sir.
So like your teacher explained how you guys should use Le Chatelier's principle.
Yes, sir.
I know this is like a bit off guard, but since I'm trying to help you to understand, can you try to state what happens when the pressure is increased using Le Chatelier's principle?
Wait.
Oh yeah.
Which question is it? Question
Oh,
6.3.
I'm sorry.
6.3.
Yeah, I'm sorry. So as I was doing this, I was busy searching about it, and what happens is that when the pressure is increased, the side of fewer moles is favored. And when the pressure decreases, the side of more moles is favored. So I'm just sorry about that misunderstanding. So what I would say is that when it comes to pressure, just know that when it increases, you're gonna go to the one with the lower moles. And when it decreases, you're gonna go to the one with more moles. So it's sort of like an inverse proportionality between the number of moles and pressure. But anyway, so that's just gonna change the answer of 6.2.2. So instead of saying that this is gonna decrease, it's actually gonna increase. So I'm sorry about that, about that mistake. But can you try like and state it with Dirichlet's principle?
I know Dirichlet's principle is basically that everything wants to stay in equilibrium. So if
Yes.
the dynamic is disturbed, then the equilibrium will shift to counteract it so that it goes to equilibrium again.
Yes. That's actually that's the concept behind it, behind Dirichlet's principle. But when you're actually when you're actually going to apply it, like there's a few statements that you need to state step by step. So that's why I'm just asking you, can you try to give it to me so I can know that you're on the right path when it comes to stating all the steps in order. But if you're wrong, I can give you I can show you how you're gonna state all the steps.
So I don't know how to answer it.
So basically what happens is that you're gonna say that when the pressure is increased, right? The equilibrium. So firstly, you have to state what happens, and you have to state what happens where the equilibrium is gonna shift. Then you state which side that shift is to. So in this particular case, let's say you're gonna say, according to Dirichlet's principle, if the pressure is increased, the chemical equilibrium is gonna shift to the side of fewer moles of gas and more moles of iodine molecules are gonna be produced and fewer moles of iodine atoms. So do you understand what I'm saying?
Yes, sir.
Yeah, so you just have to state what happens. Sometimes it's a mark, sometimes it's not gonna be a mark, but you have to state what happens. State how the equilibrium is gonna shift and state which side on your given equation is going to be favored. So let's say if the pressure is no longer getting increased, it's going to get decreased. You're going to say, according to Dirichlet's principle, if pressure is decreased, the chemical equilibrium is going to shift to the side of more moles, and more moles of iodine atoms are going to be produced. So do you understand like how you state it? It's usually a 3-mark question, but here it's 2 marks. So
Yes, I understand, sir.
okay. So Now we're going to 6.4. They say at 227 degrees Celsius. So now you're going to change the temperature. And as we know, the temperature affects the equilibrium constant. The equilibrium constant of the reaction is 5.6 times 10 to the exponent negative 12. So they say, is the forward reaction endothermic or exothermic? Now, this one is going to be a bit more interesting because if you look at it, you know the equation for Kc for equilibrium constant is the concentration of the product. In this case, it's iodine. And this is going to be squared divided by the concentration of the reactants. So it's going to be your iodine molecules. And this is going to be to the exponent 1. So first thing first, you must compare your temperatures with your Kc. So at 727 degrees Celsius is to 227 degrees Celsius. The Kc went from 3.76 times 10 to the exponent negative 3 all the way to 5.6 times 10 to the exponent negative 12. So if you look at this, at higher temperature, the equilibrium constant is higher. So that means Kc at 727 degrees Celsius is greater than Kc at 227 degrees Celsius. So you can see that part, right?
Yes, sir.
So in order for your Kc to go lower, that means the product, the concentration of the product must decrease, and that of the reactants must increase. So you understand that part?
Yes, sir.
Okay. So this means that when temperature is decreased, the products are decreased and the reactants are favored. When temperature is decreased, whichever is favored, that reaction is exothermic. And the opposite reaction is going to be endothermic. So since temperature is decreased and the reactants are favored, that means the reverse reaction is exothermic. And the forward reaction is endothermic. Since a decrease in temperature favors the reactants, that means an increase in temperature will favor the products. And the reaction that's favored when temperature is increased, that's the endothermic. The one that's favored when temperature is decreased, that's exothermic. So do you understand it?
Yes, sir.
Okay, so you don't have any questions about like how you determine this? So you don't have any questions?
No, I'm good, sir.
Okay. So just keep that in mind. So it's 4 marks. Basically, what I did, that's how I would explain it. I don't know whether you would prefer to explain it in words, but I explained it mathematically and then translated it into words. So I just hope it's not confusing for you when you eventually encounter this question in your exam. So I just hope like you know what to do. So they say a certain mass of the iodine molecules is sealed in a 12.3 liter flask at temperature of 727 degrees Celsius. And they gave you a kc unit. When equilibrium is reached, the concentration of the iodine atoms is found to be 4.7 times 10 to the exponent negative 3 moles per liter. They want you to calculate the initial mass of the molecule of the iodine molecules in the flask. So this is this has to be like one of the most interesting questions I've seen since I've been teaching these things. So I'm gonna help you go through it. Rule number 1 is that you always have to convert your units into moles. So you have your reaction and you have to convert your units into moles. So they gave you the concentration of the iodine atoms and they gave you the volume of the beaker. So you know your concentration is your number of moles divided by the volume. You have your volume, which is 12.3 liters, and you have your concentration. You can be able to find your number of moles. So your number of moles is gonna be, what is that? It's gonna be 12.3 multiplied by 4.9 times 10 to the exponent negative 3 is equal to CV. So now you're just gonna multiply these. Oh yeah, it's 4.79. Let me just erase this. Seven and 9. So 12.3 So using my calculator, I found my number of moles to be 0.0589117 mole. So let me just erase this. Zero point 0.058917 mole. So that's what that's gonna be your number of moles. And now what you're gonna do next is that we're gonna we're gonna go to our table, our equilibrium table. So let me just do this. So let me do this, and let me erase these. So yeah, now we're gonna draw our table. Firstly, we're gonna write down our chemical equation, which is iodine molecules, and they're in equilibrium with the iodine atoms, 2I. So now what comes next is you're gonna have your initial number of moles. You're gonna have your change in number of moles, and you're gonna have your equilibrium number of moles. So this is your initial, this is your change, and this is your equilibrium number of moles. Equilibrium number of moles. So initially, you're gonna have 0 moles of your iodine atoms, because if you because in the question they say they take an unknown mass of your iodine molecules and put it in a sealed container. So there was no iodine atoms in that container. So your initial value for your iodine atoms is 0. And we calculated our final value here, which is 0.0589117. So that means to find a change in number of moles, you're gonna have to look. It went from 0 to 0.058917. So that means that the moles of your iodine atoms were added, and okay, the moles of the iodine atoms were formed. That means the iodine molecules were converted into iodine atoms. So here you're gonna have a negative to show that this is converted into this. So you're gonna write your plus, it's gonna be plus 0.0058917. And here, and now we're gonna go to our iodine molecules. Since the initial mass of the iodine molecules is unknown, here you're gonna have X. You can choose whichever letter you use to represent the unknown, but I choose X. And now you're gonna use your stoichiometric ratios, where you're gonna have 1:2 for your iodine molecules, that's 1, and for your iodine atoms, that's 2. So you're gonna have X is to your 0.0058917. And then after this, you're going to cross multiply, and your x is going to be, you're going to have 2x is equal to 0.0589117. And now you're going to divide both sides by 2. So you're going to have your 2 here. You're going to have your 2 here to find the number of moles of the iodine molecules that were converted into iodine atoms. So dividing that by 2, I get x is equal to where's that text? 0.0294585 more. So now that you have this, you're gonna write it here. So you're gonna have 0.0294585. And down here at your equilibrium, you're gonna have your x minus this. So at your equilibrium, it's gonna be x minus 0.0294585. So yeah, after you're gonna use your Kc equation. So we're gonna rub everything out. And we're gonna write down our Kc formula. So our Kc is equal to the concentration of iodine atoms, the whole thing squared, divided by the concentration of your iodine molecules. And this is gonna be to the exponent 1. Oh, sorry. Since it's concentration, we're gonna have to convert this and this into concentration. So you're gonna have your C is gonna be equal to N over V. So we know that our volume is 12.3. It's 12.3 liters. And our number of moles is X minus, and it's also 0.5. So basically, you're gonna put this here, 0.5, 0.0589117. So that's gonna be a concentration for, this is gonna be a concentration for your iodine atoms, and the concentration for your iodine molecules is gonna be X minus 0.0294585. and this is also divided by the same volume of 12.3. So now you have your concentrations. You can convert them if you want, or you can just leave them like this. So I'm just gonna leave them like this and put them in brackets here. I'm gonna have 7. This is divided by 12.3, close brackets. This is gonna be divided by, oh yeah, so it's squared. This is gonna be divided by x minus 0.0294585 divided by 12.3. So there's like 5 minutes. There's 5 minutes left. Let me just screenshot this. So let me end this meeting so we can have our next meeting till 6 p.m. So just join it. Just join whenever you feel ready. So let me end this.